Okay, in this problem we are comparing the interest accrued in two cases. One, the continuously compounded interest, and interest that's compounded annually. So actually, before we get into the problem, I want to talk about the e here in this equation. Now, um, e is one of those numbers that we often use, but we don't necessarily understand where it comes from. So I want to talk a little bit quickly about where it comes from. It's like I'm assuming you've heard of this number pi before. Well, it's more common that a student has heard of pi and used pi, but not, but doesn't know where it comes from, what it means. So, like, for example, pi is the ratio of circumference to diameter in any circle. E, in this case, another one of these irrational numbers, E is defined as, um, let's say E is the limit as x goes to infinity. So all that means is you plug in larger and larger numbers for the variable x of 1 plus 1 over x raised to the power of x. Okay, so x is a variable. You can plug in any number you want. So this x goes to infinity means e is the number you get as the numbers you plug in get infinitely large. I'm going to pop over here to Excel to do the calculation. So I have x in column A. These are the numbers I'm plugging in. And here's that 1 plus 1 over x to the power of x. So let's plug in, we'll say 1, 2, 3, 4, 5. And let me, okay. And in the column B, so this should be equal to parentheses 1 plus 1 divided by the x value, so that's a number to the left, raised to the power of that same x value. Okay, so this formula is going to take the number to the left and plug it in for x. So when x is 1, this formula gives you 2. And let me round this to 3 decimal places. Okay, so when I drag this formula down, it's just gonna at each line it'll use the number to the left. Now let's use some larger numbers, maybe 50, 100, 200, 500, 1,000, 2,000, 3,000. Oh, so now that 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 output value, the y value, if you will, is starting to level out. From here on out, it's going to be 2.718. So this is approximately that number e, 2.718. As the x values get big, that the result of this formula is approximately 2.718. Uh, Thinking a bit more pragmatically, E is simply a button on the calculator. Just like there's a pi button, there's an E button. On the graphing calculator, it's right here in blue above the natural log. So if you wanted to say like E to the fifth power, you would say second ln, that'll be E to the power of 5. So it's basically giving you approximately 2.718. So that's this value of E, 2.718 raised to the fifth power. Now, why is this formula? Basically, where does this formula come from? Well, let's start with our compound interest formula that we have already. So we have A equals P parentheses 1 plus r over n to the power n times t. Now we could rewrite this. Remember, e is 1 plus 1 over x to the power of x. So whatever you have down here, you have to have up here. All right, so what we could do is take this compound interest formula and make it look like that. We need a 1 over right there, right? So we could rewrite this a equals p 1 plus, instead of r over n, we could do 1 over n over r to the rt. And like I said, these two have to be the same. Whatever's in the denominator here has to be the exponent up here. So we have an n over r, and we need an n over r up here. So let's do this. P 1 plus 1 over n over r to the power n over r to the, let's see, to the rt. So, oh, sorry, this is an n. Yeah, so that, here's your, you have nt, you still have an n and a t, that works. But we have an r over r, so that technically is equal to 1. All right, so let's see what we have here. I'll put a little red box around this part. This right here is exactly the definition of E. So here's our x. Whatever's down here is also up here. So we did a little bit of algebraic manipulation from here to here, from here to here. Each line means the same thing. We've just sort of rewritten it in a way that, we're motivated by this guy. We want to make it look like this. So basically, we tweak this compound interest formula, which is here, and we shuffle things around, and we use reciprocals and times and divide. So we have this E here. And so continuously compound interest means as the number of compounds per year gets infinitely large. So as n, the number of compounds per year, goes to infinity, that's like saying in the definition as x goes to infinity. So this becomes the number E, and so the result here is as the number n gets infinitely large, this A, this A right here, gets closer to P. What I have in that red box is the number E, and then you have this exponent left over, power of R T. So this is where the E well, this up here, I'll put a green circle around it. This is where E comes from. This is the definition of E. So what we do is we take this equation and we rewrite it so it contains something that looks exactly like this. And then this here, this becomes the number E. 1 plus 1 over something raised to the same something. Okay, so now we have our compound interest formula. We could go back to the problem. So that's this guy. Find the future value with interest compounded continuously, and find the future value with interest compounded annually. So for the first one, interest compounded continuously. So that's A equals principal. In this problem, it's 13,000 times, oh, we don't need that parenthesis, times E to the power R times T. So the R is the rate, that's the 0.04, and T is 10 years in this case. Okay, so 13,000 E to the 0.04 times 10. So I'll come over to the calculator again, and let's just type it in exactly as it's given. 13,000 E raised to the power 0.04 times 10. Exactly as we have here. Let's type directly into the calculator, and let's see. So we've got about, let's go back here, $19,393.72. $19,393.72. All right, so there's our answer for part A. For part B, compounded annually, well, now we use our compound interest formula. That's, if I go back to the other slide, that's this first one we started with. So we'll use this guy. P 1 plus R over N to the NT. I'll come back here, I'll free up a little space up here. Okay, so for compounded annually, A should equal, that's an equal sign, principal, 13,000, parenthesis, 1 plus R over N, so it's once a year, to the power N times T. And those two ones we don't really need, so we could just say 13,000. 1 plus 0.04 to the power of 10. We can pop that into the calculator exactly as it's given. 13,000 parentheses 1 plus 0.04 close parenthesis, and we'll raise that to the power of 10. So $19,243 and about 18 cents. So we see about approximately $150 difference. In part C in this problem, you'll say the account earns, you have to subtract these two numbers, your answers from part A and B, to get the difference. It's part C. Okay, yeah, and it's always good for this number E here, it's always good to understand where something comes from. If you're going to use it mathematically, it's a good idea to understand it. Alrighty, hope this helps.